Good morning, one and all. In this third lecture of surface tension, you are welcome back. Again, this lecture is for BSc first year physics students. Second unit surface tension. And in this surface tension, we are discussing today an important method how to find out the surface tension. And this method is Jigger's method. Having surface tension of a liquid by Jigger's method. Already you are familiar with the concept of surface tension. In last lectures we have seen the surface tension. So principle of this surface tension is what? Excess pressure. Excess means more pressure. Where inside the liquid drop is greater than the outside pressure by 2T by R. Where T is surface tension of the liquid and R is radius of the liquid drop. See, in this experiment, the experimental arrangement is given first. I'll show you experimental arrangement first. Here you see this B is the tube. The capillary tube is fitted to B, and this B is, tube is placed inside the liquid, water, whose surface tension is to be found out. Here PA shows here what? It is atmospheric pressure on this water. Suppose height of this tube is, capillary tube is in the water level, it is H, capital H. So there exists a pressure on this bubble. That pressure is said to be outside pressure. So you remember only this is a tube, B is a tube connected to capillary tube. Capillary tube is placed inside the water. See here, inside the pressure drop. Now let us turn towards second arrangement, that is inside the pressure. Here there is a manometer. Manometer is connected here, and it's suppose difference in water liquid level of the manometer is capital H. This point you remember. Now third one is there is a funnel, Fisher funnel. Here this is a stopper and tube A is there, and this bottle is said to be Wolff's bottle. Such a Wolff's bottle has two openings. In one opening, a thistle funnel is fitted with a stopper. Another opening, a tube A is connected, and you remember here tube A, and here this thistle funnel is filled in the water. Its end is in the water. This point you remember, and this bottle is said to be Wolff's bottle. Got it? This A tube is connected to B through manometer. This point you remember. And then the whole arrangement I will show you like this. What is this? This is a capillary tube connected to B tube. Its height of the capillary tube from this water is capital H, suppose. Manometer height is H. Difference between these two liquids. A is the tube connected to the Wolff's bottle like this. This is a thistle funnel used to add water in this Wolff's bottle by using stopper. This is the experimental arrangement to find out surface tension by Jigger's method of a liquid. See here, actual procedure is like this. initially we have to start a stopwatch or stopper here and allow to fill water in this Wolf's bottle slowly. Slowly means very slowly, drop by drop. Slight opening we have to open of the stopper and allow to flow liquid in this Wolf's water. Because of this water occupying room in this Wolf's bottle, the pressure of the air causes, and this pressure of the air happens to be here. If the pressure goes to tube A and to the manometer like this, and here the level of the liquid in the manometer raises, and here goes down liquid, and the pressure also goes towards the tube B, and here continuously water is going to supplied, continuously air pressure is going to come here, and here we get the drops, bubbles we obtain. Here pressure in this manometer, here pressure in this capillary tube. These pressures are said to be pressure inside the bubble. Got it? Pressure inside the bubble. Then this pressure inside the bubble is going to work against two pressures. One is outside pressure, outside the bubble. Other one is atmospheric pressure, and about surface tension also. So as soon as if we on the stopper, then water flows down, air pressure comes here, and manometer shows reading. Here we will obtain the bubble. But this flow of water through the fissure funnel is going to continue. Then what happens? Bubble starts to increase its radius. And here you have to consider that the radius of the bubble is nothing but radius of the capillary tube. I mean, diameter of capillary is same to the diameter of the bubble form. The diameter of this capillary tube you can calculate by using traveling microscope also, so that we can obtain its radius. I mean, radius of the liquid drop easily you can obtain. Yes or no? Suppose its height level is this, its density is sigma, its density is rho, suppose rho, density of this liquid is rho. Then what happens? One stage will come. The principle of this surface tension in this case is what? Excess pressure inside the liquid drop. Here I have shown you different colors. Black color shows here the surface tension is inward in the drop, liquid drop this is. These pink color shows the pressure, outside pressure on the liquid drop, and this color shows the pressure on the liquid drop through inside. I mean, this inside pressure is working against these two pressures, outside pressure and surface tension. So this inside pressure is surely what? More. How much it is more? That is our principle. This principle is nothing but the excess pressure inside the liquid drop or bubble is greater than the pressure outside. It's by 2T upon R, where T is surface tension and R is the radius of the bubble. You are getting it? Then let us come to the next slide. What is this? The radius of the bubble. Bubble which is formed at the end of this capillary tube. It has radius and it is equal to the radius of the capillary tube. It can be obtained by using, or it can be measured by using traveling microscope. Now let us see. One stage will reach as stopper is on, slightly liquid is coming through fissure funnel, pressure on the bubble is going to be continuous, and one stage will reach. There the bubble, what happens? Breaks. Here just before the bubble breaks, what happens? Pressure inside the bubble, P inside is equal to Pi, it is equal to rho GH plus Pa, where rho is density of the liquid, G you know acceleration, H is what? Height level of the capillary, Pa is nothing but atmospheric acting on it. Similarly, pressure outside PO is nothing but sigma GH plus Pa, where sigma is what? Density of the liquid in the manometer. Already we have seen. Subtract this 2 from 1, equation 2 from 1, then what happens? Pi minus Po is equal to this minus bracket this. Removing bracket we will obtain Pi minus Po is equal to rho GH, Pa gets cancelled, plus minus, and G is taken common, rho H minus sigma H. But we know that Pi minus Po, this difference is nothing but what? 2T by R. Therefore, 2T by R is equal to that expression G rho H minus sigma H. T is equal to 2T is equal to R goes to numerator, R into G into rho H minus sigma H. Therefore, T is equal to this 2 goes below, R G rho H minus sigma H. In this way, easily we can obtain surface tension of a liquid by knowing acceleration due to gravity you are well known. Radius of the bubble you have to obtain. Density of the liquid is known to us. Height level is known. Density of the liquid in the manometer is known, and its level, height level, is to be calculated by using manometer reading. In this way, by knowing all these terms, you can utilize this formula and you can obtain the surface tension of the water. Here, atmospheric pressure on both is what same, that is A. It is shown by Pa. Pa is shown and it is same at both. Here atmospheric pressure is same, and here atmospheric pressure is same. Here atmospheric pressure is same. That's why we are going to cancel Pa plus and minus term. Here we are getting to be cancelled. The remaining matter is what? G rho H minus sigma H, where G is taken common and we obtain the expression, final expression, T is equal to R into G by 2 sigma H minus sigma rho H minus sigma H. So in this way, knowing the terms, various terms, we can obtain the mathematical expression. We can obtain the surface tension of the liquid. T is equal to Rg by 2 rho H minus sigma H. So in this way, in last lecture we have seen about the excess pressure inside the liquid, and here we have obtained the same relation by using Jigger's method. So in the Jigger's method, only apparatus you remember, its working you have to explain. If question is asked in examination, then how it works, how it is working, all these things we have to mention. One thing remember, this stopper yes should be what? Slightly open, so that one drop by drop liquid comes below and here pressure increases. This point you have to remember. And here this is surface tension number 3, third lecture. So you go through YouTube, and if any doubts you have, you ask, and if you have any queries, you discuss with me so that you will be satisfied. Thank you.